All right, welcome, folks. I know a number of people are joining in, so thank you very much for tuning in on your lunchtime or whatever time you're here now. And today we're going to be getting into a couple different topics: 9540A, some associated standards around that, and UL 3141. So appreciate you taking the time, and also happy Lunar New Year to those that celebrate. Year of the Snake, and so excited for that, and yeah, wish you all a happy New Year. For those of you, I'm going to just kind of jump right into it. I know we have a lot to talk about. So for those of you who aren't familiar, my name is Ryan Mayfield, founder of Mayfield Renewables. And Mayfield Renewables, we are a engineering consultancy. We do a lot of work in the solar and solar plus storage industry. And we have consulting engineering, project engineering, and then a lot of education and training. And so this falls into that education and training. And part of what we do is put out this type of content, both, we have paid content and content like this where we're talking about topics that are important to the industry. And this is a big one. And both of these topics are pretty big ones that we've been talking about a lot lately. So happy to talk with folks. If there's a way of supporting you in your business, feel free to reach out, and we'd love to talk and see if there's a way of doing that support. So today, so we have a quick poll just to kind of get a sense of the audience there. And then today we're doing something maybe a little different. We've maybe done this once or twice before, but in a lot of our AMAs, we bring in outside voices from the industry. And today we are focusing internally. We have a group from our own team that's going to be spending the hour talking about these topics. The four of us and the engineering team as a whole, the company as a whole, we've spend time talking about these. But I'm excited to have these three guys join us: Lucas, Tyson, and Yogesh. And a big part of it too is introducing Yogesh as part of the Mayfield Renewables team. He just joined. So real quick, I'm going to have you guys do an introduction for yourselves. It's kind of how I normally go about it, so I won't break protocol there. And I'll just kind of go left to right. So Lucas, if you want to kind of start us off, and your role at the company, and just kind of everything that you're doing here.
Yeah, thanks, Ryan. Really excited for this one. So I'll try to be quick. My name's Lucas Miller. I'm a senior engineering consultant with Mayfield. Been in the PV industry since about 2017. A lot of my day-to-day work is working with the guys on this call to develop training curriculum, whether it be online courses or working with manufacturers and developers for recurring monthly training sessions. So topics we're focused on today have been a lot of the courses we've been working on recently. So I'm very excited to chat with this group.
Awesome. Tyson, you want to introduce yourself for the audience as well?
Sure. Thanks, Ryan. Yeah, my name is Tyson Bitrick, and I've been in the space, the energy storage space and PV space for about 5 years. I've been with Mayfield for about a year and a half, and similar to Lucas, a lot of work in education and also supporting efforts around microgrids and some feasibility as well. Happy to be here.
Awesome. And then Yogesh, I wanted to just take an extra moment and kind of introduce you to as a part of the Mayfield team as a whole. You've been in the industry for a while, so some folks on the call may be already familiar with you. And yeah, excited to have you on the team. Having you join was a big thing for us. And so yeah, just kind of talk about, I guess, a little bit on your history, where you're coming from, and also, yeah, the role you're playing. I know it's still really new, but the role you're playing here at Mayfield.
Yeah, thank you, Ryan. Hello, everyone. Yogesh Singh here, principal engineer at Mayfield Renewables. I've been in the industry now for 28 years, a long time with Westinghouse and Siemens, and then subsequently with NAND and Motive Energy. Significant background in development of energy storage systems as well as deployment. I've been on the standards committee, more specifically UL 9540A, and in the process of deploying, I know some of the pains that developers and EPCs feel when the regulatory environment is uncertain. So excited about today's session on 9540A and 3141 and how it advances the industry.
Great. Yeah, and build a little bit on that, kind of the background you have of, you mentioned knowing the pains of contractors, everybody involved, you were working as an EPC, you had your company, and so definitely be on the foreground of all of that, understanding what the conversations with the AHJs have been, what it's like to be making a constructible system and those kinds of things. And so it's a really big aspect, I think, of what you're bringing to the industry and being able to help support clients with, and just bringing that knowledge as a whole. So yeah, thank you all for agreeing to join. I know that sometimes it can be not people's favorite thing, but I think the three of you are more than willing to do it, and very much qualified to talk about all these. So we're going to jump into it. Staying ahead of the curve, updates on 9540A, 3141. As I mentioned, especially on the 9540A stuff, there's some ancillary, some additional codes and standards we'll talk about that go along with that. And one thing I didn't mention this in the beginning, as we're going along, very much encourage questions. We had some folks send some questions in ahead of time, so we're going to try and incorporate those in. We had some that we want to make sure that we highlight. There's part of the conversation as a whole. But as we're going along, questions are very much welcome. If you throw those into the Q&A section of the webinar, not the chat, it'll make sure that we actually see them. Makes it much easier to manage. So that's welcomed and encouraged in the Q&A section. So we're going to start off on the 9540A side of things. This is wasn't intended to, but it was a very timely topic with what has recently happened down in Moss Landing. With lots of conversations around fire safety and energy storage systems. So to kick it off, I just want to kind of, how we're relating the different codes and standards for our systems. And we see 855 on the left, we see IFC on the right, and both of those really feed into UL 9540A. And maybe just to make sure the audience at large is on the same page as what we're talking about, I want to make sure we differentiate 9540, which is the actual listing. So that's the safety listing for the product itself, versus 9540A, which is a testing protocol that outlines, really 9540A gets into thermal runaway of our systems. And it's a testing, we're collecting data, we're doing tests. And so there is a difference between the two. Just want to make sure that we're all on the same page there. But as we go along, we're going to see that the standard for installation of stationary energy storage systems, that's NFPA 855, has relations to 9540A, as does IFC. And so I think maybe kind of talk a little bit, open this up to the group here. And, Yogesh, you've sat on the technical committee on 9540A. So love to hear your perspective on just kind of the relationship of these codes and, kind of how the interplay of them.
Yeah, the UL 9540A is a performance standard, and by itself allows us to characterize how lithium-ion based systems have hazards and how they manifest themselves. But when it comes to deployment, it's NFPA 855 that takes some of the work done under UL 9540A and packages that into guidance when it comes to, for example, setbacks from buildings or from ventilation exhausts or separation between units. So it takes some of the work done by characterizing how these systems fail to help with deployment. And the IFC sits one level above that and essentially formulates the legal framework under which everyone is expected to use these codes, because the IFC is often a part of local building codes. So there are codes, standards, and legal requirements, and that's how these three things will wrap themselves together.
Yeah, I think that's a good point, and that's something that I get asked often is, the relations of 855 and IFC. Which one should I, as an EPC, which one should I be following? And the IFC is the code that is the legally adopted code that your jurisdiction, well, if your jurisdiction has adopted IFC. Some are NFPA 1, so that's NFPA's fire code. There are some jurisdictions across the country that have that as opposed to IFC. Vast majority are IFC though. So that really becomes, Section 1207, that deals with energy storage systems. That is the code. That is what your AHJ is going to be inspecting to, is an important part. 855 is an installation standard that we should be following, but that is not one that the authorities having jurisdiction are going to be using as their guideposts, if you will. So Tyson, I'm going to kind of pull you into this as well. And so one of the things, I'd like to kind of suss out a little bit is we do have some differences. 855, 9540, IFC, they do have some, not to try to, they do have some differences in the way that the language that they use, and specifically around propagation, thermal runaway. And so I'd love to have you kind of just talk us through a little bit. 9540A is testing for thermal runaway, so a little bit about what that really means, and then how IFC is, I guess, differentiating what their requirements are.
Yeah, sure. And I think Yogesh characterized the 9540A test method quite well by saying it's a characterization, right? So a lot of folks look at it as, hey, did we pass or fail? Did our product pass or fail this? But really, the goal of this test is to gather data, specific moments in a thermal story of when the product's ability to dissipate heat is overcome by the ramping up of heat, right? So there's some technical language around this, but I think it's good to notice that UL 9540A is characterizing not active fire, but something called thermal runaway, right? So that we don't have the title of the standard there, but it's a test method for evaluating thermal runaway, not active fire, right? And so when you look at the details, and we don't have to get as much as we might like to get in the nerdy code moments and 1207, et cetera, IFC is want to use phrases like a fire involving one ESS that will not propagate, a fire that will not propagate to an adjacent ESS, right? Whereas the NFPA kicks it to UL 9540A directly, and within the module and unit level tests, the language used by at least the 4th and current edition of 9540A talks about an internal fire condition called thermal runaway, which is not an active flaming fire. And this has some pretty important consequences, this language difference. Sometimes it comes down to almost like legalese level language discrepancies among our codes and standards. So hopefully that captures a little of the flavor you're pointing to.
Yeah, and I think the big thing is, I talk about this as being a disconnect when I talk about this sometimes, and it's maybe an unfortunate part. It's something that it's where we're at, quite honestly. And we're going to, in the next slide, we're going to talk about this interpretation of 9540A, how some jurisdictions are looking at this and what they're requiring. And so there is this relation between all of them. And we actually got a good question ahead of time, and I want to just kind of bring it to the group. And so it was Ken from ESS asking us about the relationship of 9540A and B. We're probably not going to talk a lot about B just because that's a residential application and it's still under development. But B is another thing that's out there that's being worked on. And then we're also going to talk about a CSA standard that's coming up. But the relationship to 855, and so what are these connections? And Yogesh, maybe this will be a good one for you. Kind of what are the connections between the UL standards and 855 specifically, and I'll throw in IFC there, and how are they meshing, and how does the requirements in 855, I guess, how should our audience be looking at this and knowing that they are being implemented?
Yeah, so the UL 9540A large scale thermal runaway test rolls into the qualification standard, which is UL 9540. because 9540A is only a performance standard. And put together, they are then used to interpret the various codes present inside NFPA 855. The first relates to size. How big of a system am I allowed to install? And what are the requirements associated with them? So if it is lithium ion and I have some of the work done under UL 9540, 9540A, I can go up to 600 kilowatt hours. If I go above 600 kilowatt hours, I have to do something called a hazard mitigation plan. So the work done under 9540, 9540A is then used to interpret what NFPA 855 is telling me on making the deployment of these systems safe. Another area is setbacks and gaps between two units. As we know in CNI space, real estate is very precious. Many times customers may not have parking spots to give up because of occupancy requirements. The more closer systems can be installed can be of tremendous value. That is another guidance that can be obtained from NFPA 855 based off of what we have learned in UL 9540A and 9540. And finally, there are, as the standard is evolving, there is guidance on deflagration venting that provides other ways for developers to know if the system can be installed, for example, near a school district or in a hazardous zone, and what system safeguards are needed for tying the fire alarm systems in the overall energy storage system to the facility fire alarm system. So these are some ways in which the characterization and performance under 9540A and 9540 are then used in conjunction with 855 for deployment.
Perfect. Yeah, thank you. So getting these to the connection on these is really important. And I see that there was a comment, Matt Pace, thank you very much. Make sure I didn't mischaracterize the enforcement of 855. So that IFC, the code, does have references to 855. So therein by is, having that be enforceable for those requirements, though. So through those different fire codes. So thank you for making sure that gets characterized right. And so we do have these requirements. We are going to be looking at 855 for the requirements for our installations. And so I'm going to move on to the next slide here, and a little bit on kind of starting to differentiate a little bit more between the large scale fire test and thermal runaway. And I think this is an important distinction that we're seeing. We have a snippet here from San Jose Fire Department that you can see. This is a bulletin that they put out. And the kind of the takeaway that you see there that we're quoting there on the left-hand side, talking about thermal runaway testing is not equivalent to large-scale fire testing. And this has left jurisdictions with the having to make the judgment call based on that 9540A testing. We are getting good data. We're getting good information from that test, no doubt. But the question very often can become, well, we know what happens in a thermal runaway event, but we don't necessarily know what happens in a fire event. And because 9540A doesn't have that requirement to actually ignite anything. And so I guess just pointing this out, open it up to the panel and see, kind of what ideas you have, or, just comments that you have on this. And we're going to move into, what a large scale fire test is next. But this is something that, has definitely put the industry or the AHJs especially in this position of having to do this analysis.
One aspect where I think this will be very helpful is, the large prevalence of lithium iron phosphate systems. And there is a perception that lithium iron phosphate will off-gas a lot before it really is in a large-scale fire event. And I think some of the clarification with this language, thermal runaway versus large-scale fire, and the subsequent CSA 800 standard, I think will help relieve some of the concerns, very legitimate concerns fire departments have with the large prevalence of, let's say, lithium iron phosphate systems, which off-gas a lot earlier, more intensively before they see a large-scale fire. And to be clear, lithium iron phosphate will eventually get to a large-scale fire. It's just later in the time scale.
Yeah, and I think that's a good point. Just in terms of there are different chemistries within, lithium ion. I know some people, it really drives people nuts when we lump everything under the lithium ion. I've kind of had those conversations before, but that is how the 855 really, lithium ion is the characterization. And we do have different technologies, different chemistries that react differently at especially different temperatures, as you were just mentioning there.
Yeah, and I think that's a really good point about the perceived and actual safety benefits of LFP and its prevalence right now in the market, as Yogesh just mentioned, and that it's not therefore fire safe, so to speak. But what we're getting at here is the prevalent subchemistry is prone to some off-gassing. And if we look back at the way that 9540A was originally set up to characterize thermal runaway, there isn't a lot of coverage of what happens with off-gassing, and namely, there isn't any requirements to use an open flame source or any sort of ignition source whatsoever in the 4th edition of 9540A. And so this is sort of previewing where we're headed here into what are the requirements, or what are the necessary features of what a large-scale fire test might be, including intentional ignition.
Yeah, and Yogesh, you have mentioned timescales there, and I think that's a helpful framework for those maybe who aren't familiar with what thermal runaway is as a process. When we're doing these thermal runaway tests like 9540A, we're oftentimes just heating up a cell. And so our imaginary graph here is time versus temperature. And as we're heating up that cell, the internal pressure is building up and building up and building up. At a certain point, it will have to vent the internal gases inside the cell. And that happens prior to reaching the point of thermal runaway for a lot of subchemistries. And so a big risk here is that invisible risk of off-gassing that can occur in that process of heating up the cell, but even prior to thermal runaway. And so one of the gaps here that we want to close is lighting that off gas on fire to fully ignite the battery and then assess what happens.
And last thing I'll add, I'm excited to see a little bit more emphasis and growth and development in fire suppression agents and early detection sensors. And I think some of this emphasis on large-scale fire testing, as opposed to just thermal runaway testing, will bring the microscope under, let's say, a clean agent, and how effective is a clean agent, or how effective are certain early detection sensors. Our industry needs that, and rightfully the focus now will be on a lot of those ancillary systems.
Great. Yeah, and I actually see another question that came in, and just a point of clarification, and I think this is it's good to reiterate, say it, I guess maybe in different ways of, so a battery, the question is asking about thermal runaway versus fire. And so a battery system, we can drive into thermal runaway, and it may never actually have a flame associated with it. It may never actually catch on fire. And that is a true statement. That is something that we are seeing. So 9540A itself requires that, and we don't have it here, but there's a whole series of, from the cell to the module to the unit to the installation. So there's different steps within doing the test, but we are able to drive cells into thermal runaway and not actually catch them on fire. And so a large scale fire test, and hence what, in this case, the San Jose Fire Department is saying is we are getting data from 9540A, but that data does not necessarily tell me, the fire department, what happens if an ignition source happens and those gases catch on fire. And I think that's the big question that we are needing to answer to alleviate concerns around a fire ignition, because the batteries themselves, we may not actually catch fire, but there could be an event, something, there could be a spark from on the electrical side of the system that would actually catch the gases on fire. There's other events that could happen. We've seen seen reports of water being introduced into battery cabinets because what you were just talking about, Yogesh, the fire suppression system enacts and creates a short, and then that creates a spark. So there's different ways that we can see this, and 9540A is not requiring that we do that.
Another subcomponent that could lead to a fire is a UPS. UPSs are often lead acid. They are present inside the enclosure. They are not part of a UL 9540A thermal runaway test, but can contribute to an independent fire. And from a fire department standpoint, they have to deal with it regardless. Whether it came from cable sheathing, it came from a lead acid UPS, and the system is on fire, the impact to them is the same. And this is the recognition of that.
Yeah, and I think
Correct.
it's good to remember like the how wide the table is as far as folks who have a vested interest and are excited about deployment of energy storage. This includes our fire service folks. And if we look at the introductory chapters of the California Fire Code or the International Fire Code, that stakeholder, our service folks who are charged with coming to an unfortunate event of a possible fire, their well-being should also be right at the front of our minds with some of this. And so explosion risk compared to an active fire risk are very different animals for a fire service team to tackle. So it's not uncommon for fire service folks to prefer an active fire over a potential explosion in the making.
No, that's a great point, and that's something that we've talked with folks. Matt Pace comes to mind. Folks on the call probably recognize Matt, and that's definitely been a point that we've talked about, through PNNL and some of the work that he's done and others have done around that. So the unknowns, one of the big events that, unfortunately, the unfortunate events that happened was down in Arizona. So there's a lot of information around that. And part of that was there wasn't an active fire, and then the firefighters opened the door, and that was, what initiated in more of an explosion. And so that's what we're trying to avoid. We're trying to make the systems safer for first responders, and making sure that we're avoiding these situations to begin with. Okay, so I think that leads in well into the CSA. So one of the things we're moving away from talking about 9540A specifically, and moving into CSA. So CSA, another nationally recognized testing lab that, they're one of, I believe it's 19, if I have my number right, that are out there, NRTLs, NERTLs, and they are in the final stages. It's not a consensus standard yet, so I think I want to be very, very clear about that. They're in the final stages, but they are not a consensus standard at the moment. You can purchase CSA TS800. It's a large scale fire test, and what the goal here is, and you can go through and you can read the scope and everything about CSA TS800. The goal here is to answer that question that the fire service and a lot of the industry is asking is, well, we have thermal runaway, we have hazardous gases being released, they're flammable. What happens if and when they catch fire? What happens to the system as a whole? And so I know that this group, you've looked at the that standard, and kind of what it's what's going into it. So I want to kind of dive into that a little bit more. But this is, somebody asked the question, does we just use San Jose as the example? The question is, well, I guess, what is San Jose not allowing or disallowing with this? And really, there's a section in 855, I think I glossed over this. 855 tells us that we have specific unit level, like the energy capacity we can have in individual units. And then it also says the spacing between those units. And so we have, for commercial systems, each unit cannot be more than 50 kilowatt hours. And those individual units need to be spaced 3 feet apart, unless there is testing that shows that that there's large scale fire testing that we can place those closer together. So this is helping close that gap and helping us show, if done properly, and the data comes back and says, yes, you can actually put those closer than 3 feet together, or you can put more than 50 kilowatt hours in those units, because we've tested it. We've actually done a large scale fire test, and we know what will happen to adjacent units. I guess, Lucas, I'll kind of pull you into this a little bit too. And I think the question is just kind of, I know that you've read through CSTS 800, and so part of the protocol, if I remember right, is, I'm kind of looking to you to verify. So we have a unit that's under test. And so we have a picture here from BYD. They've gone through and they've released this. This is on, there's a video that they released on LinkedIn that you can watch of this test happening. And if I remember right, the unit under test has to be fully charged. It has to be at 100% state of charge. And then the units adjacent to it have to be installed per the manufacturer's instructions. So you can see here we have a couple cabinets pretty close together. I don't have a tape measure, but that looks to me, well, that might be 3 feet. I don't know. Hard to tell from the scale. But nonetheless, those adjacent units also have to be populated with, at least partially populated with, batteries in order to test what the fire will do.
Yeah, that's all correct. So if you imagine kind of an aerial view of this test, we have what we call an initiating unit, the one that's very obviously on fire, and then our target adjacent units, which are the ones on either side. The setup for the test will be all based on manufacturer's installation instructions. So again, thinking back to those 855 unit spacing requirements, if we want to bypass that and install our units closer than those requirements, this is where we go about that test. So if it's a 6-inch separation, a 1-foot separation, we'll install them accordingly. And the initiating unit will be fully populated, 100% state of charge. And the adjacent units, I believe at least one live module has to be populated at 100% state of charge. And that module has to be arranged close to the initiating unit. So again, looking at our photo here, unit on the left's on fire. That means the modules on the leftmost side of that non-ignited unit are populated, are at 100% state of charge. And what we're doing in the initiating unit is starting a thermal runaway reaction. We're generating a thermal runaway response and then igniting those off gases. And a lot of the language in CSA TS 800 relates to really ramping up that fire. We were looking for the worst case scenario. So we want any vents or fans open to get as much oxygen into that fire as possible. And we want to burn up as much of the fuel as we can. So this is almost a worst case scenario analysis that we're looking at. And we're trying to assess, what does the fire jump from this initiating unit to any of the adjacent target units? And if so, what happens? What does that look like?
Great. Yeah, and so again, we're trying to close that gap of, what is a large scale fire test versus 9540A, and giving the AHJs really good data, really good information on what happens under those really worst case scenarios like Lucas was talking about, and making sure that we are mitigating whatever risk we have as much as possible. So this is one to look out for. This is, again, a standard that CSA is finalizing, though they should have out in this calendar year. With standards, it's, we can't ever give a specific date just because a lot of work has to go into those. But that is something that we'll be looking forward to being able to utilize. And so a question that we got previously, I've gotten before, and I don't know if I can answer this with, absolute definitive answer, but the question is, well, once CSA comes out, there's a consensus standard. Will jurisdictions accept this, and will accept this as, being able to maybe move your units closer together or something like that? And, I can't say for certain that they would, but once we get into consensus standard territory, once we get it into that level, I would expect that this would make jurisdictions feel much better and be able to accept those. And I think the other big part of this is getting these standards written into things like NFPA 855 or referenced in NFPA 855 and IFC, which both of those are, as I think Tyson mentioned earlier, NFPA 855, the 2026 version is, really all but done. And so we're, another cycle away before adding anything like that would be in play. I guess curious, Yogesh, from your sense on that of, acceptance from authorities and things like that once CSA does have it as a consensus standard.
I'm looking forward to it. Once it is a ANSI consensus standard, we will see more and more acceptance from fire departments and AHJs as their inputs would be incorporated, primarily because it's in the interest of the AHJs as well to adopt this and bound the response that they have to be prepared with in case of an event. This helps the jurisdictions as well in their preparedness. So I'm excited to see, when this becomes a consensus standard, and I expect it to be adopted very quickly, both by developers and by AHJs.
Yeah, I would agree with that. Okay, so we had two topics we want to talk about today. So I want to kind of wrap up 9540A and fire testing here with this slide, and really just kind of a big overview. And Yogesh, I'd love to have you kind of walk us through this and, high level, set up kind of a timeline here to just give people a sense of, quite honestly, how short-lived this whole thing has been. If you look back, 2016 is when we're starting our timeline, and we're in the beginning of 2025. So this is not, we have not had a lot of standards. We haven't had a lot of good codes and standards around this for a very long time. And so we're seeing the implications of that with issues like what just happened down at Moss Landing, systems that were installed, arguably systems that are probably not going to be installed again, but also, having to use best judgment, best engineering practice at the time. So yeah, I guess, Yogesh, if you wouldn't mind kind of just highlighting some of these things for the timeline on these fire tests.
Yeah, I view regulatory standards as an aid, as a help, as something that brings deployment forward. I know there is a perception that regulatory codes and standards can be a burden, but this timeline will help us understand how it has actually helped bring the industry forward. So think of the time before 2016. Any system larger than 600 kilowatt hours was open to interpretation by the local AHJ and fire departments. They could say no. The separation distances were large. That was an issue. When in 2017, 2018, the first 9540A as an outline of investigation was published, it actually provided guidance on systems greater than 600 kilowatt hours. It actually helped reduce exposure distance to exits and building setbacks and HVAC systems. So there, directly we can see how the standard has really helped to bring the industry forward. In the next 3 years, from 2019 to 2022, the updates to 9540A have been a refinement of those test procedures as more and more folks adopted it, and integration with NFPA 855 to aid deployment and help AHJs. So there again, those changes, evolutionary changes that came to 9540A in those 3 years have brought the industry forward, and that includes expanding other battery chemistries. Today, we are seeing, with CSA 800, another gap being filled, which is large-scale fire as opposed to thermal runaway. So again, as deployments have increased, technology has evolved, that regulatory landscape is catching up and is providing a framework for deployment and creating trust. So prior to 2016, there were a lot of trust issues with lithium-ion systems, but as this timeline has progressed, the standards have come into place. They have evolved to adapt to situations that have arisen, and as we are filling gaps with CSA 800, I think it is also addressing that trust gap. So I wanted to offer that perspective that regulations can be your friend.
Yeah, no, they definitely help us as an industry, help us as as an industry, making sure that we have better and higher quality systems for sure. Couple questions that I came in, and then we're going to jump out of this topic, but they were good questions. I think there were ones that was worth noting here. So the question for Mark was asking about, so we talk about CSA 800 as a testing standard. Will CSA be the only NRDL that can test to that? And the answer to that is no. So test standards, once they become consensus standards, finding the big point, and this holds true for UL standards as well, is that they are a repeatable test. So other NRDLs, you would have to be a NRDL in order to perform the test, and you have to take it one step further. Just because you're a NRDL doesn't mean you can do every single test. You have to get certified for specific tests. So my understanding, I may be off on the specific number, but there's something only like 5 NRDLs out there that can actually test to 9540. And so in order to be a NRDL that can do the test, you have to get registered and have the proper equipment and all of that, but it's not limited to just any one NRDL. They don't get the monopoly on doing all of the testing. So we'll, definitely see that out there. And then the other question from Jonathan was asking about, what are the codes? We talk about this CS 800. What exactly are the codes that are kind of helping us point us to using that data that we're getting? And so what I would say there is 1207 in the IFC talks specifically about, and I'm sorry, I don't have off the top of my tongue the exact code sub-reference, but in there, IFC does talk about doing large-scale fire tests, 1.7 maybe, somewhere in there. It's in the front part of an IFC, but they talk specifically about large-scale fire tests. And then on top of that, NFPA 855 2026 language, we will be seeing very explicit talking about large-scale fire testing on top of 9540A. So they say 9540A and large-scale fire testing. So we do have some references kind of pointing us to those. All right.
And just to piggyback on that, Ryan, yes, I was just about to respond to a similar question. And the draft language for the 26 NFPA 855 is more or less locked in. The first draft will be available on March 6th. And that's that key section we had up earlier, 915. That's exactly right. It's including an and statement. It'll say, in accordance with UL 9540A and a large scale fire test. And so this might be more of a question than an answer to you and Yogesh, but is it the case that a consensus standard is when it's explicitly written in our codes? Is that the case? Was that the case for UL 9540A as soon as it's in Chapter 9 of NFPA 855, as soon as it's in Chapter 12 of IFC, that's when it becomes a consensus? Or when we use the term consensus, I just want to sort of be specific about that if we can.
Yeah, so a consensus standard would essentially mean it has got participation from all stakeholders. So that would be utilities, counties, fire departments, also EPCs, developers, folks who are building the systems, and other NRTLs. So once it has gone through that process of open for comment and discussion and acceptance from all these entities, that would make it a consensus standard.
Gotcha. So we've got the 40A equivalent already published. It's on our timeline here. That was in December. And we have the CS 800, which is the standard that you would list to, that's forthcoming, right? And
Yeah.
it's part
And
of
it does
that
take
process.
time. It does take time because every edition has to be put out for a specific duration to allow for open comments and for discussion on those comments and resolutions. So we ask folks to be patient. It does take a little bit of time for building a consensus.
Perfect. Thank you.
And that actually, ties into this next discussion. So we are talking about another standard. So I'm going to shift gears. Not surprisingly, we all predicted this as we were preparing for this, that we were going to spend a lot of time on 9540A and the fire stuff. But we do want to, wanted to talk about this, and we have a little bit prepared. So there is again, shifting gears here away from energy storage specific, moving into energy management systems, power control systems. And so gonna talk about a new standard that's coming in, another one, UL 3141, and kind of its relation to UL 1741. And so I first wanted just to kind of set this up, and then I'm gonna have Lucas and Yogesh kind of take it over. But for those of you out there, working in the industry, installing systems, those kinds of things, the real world, implication for you is going to show up in National Electrical Code 705.13. And that is where we talk specifically in 2023 about energy management systems. In 2020, if you're still in that code cycle, it's power control systems. And then there's additional push into Article 750, which is energy management systems as well. And so that is kind of the real world, why we're talking about this. Not that you as an installer, if that's your role, are going to be going through these standards, but kind of the why behind it or what's driving it. So with that, Lucas, you want to kind of give us the big overview on 1741, the CRD, and 3141, kind of that relationship of those?
Yeah, and I think it's a really exciting topic. It's really broad, so we could spend another 3 hours just chatting here. I think this one's also really important just for the energy transition overall. We had an internal call yesterday looking at the history of the grid. We're kind of moving from centralized large thermal plants that are far from people actually using that energy now to more distributed energy resources that might be in someone's garage or in their backyard. And with that, we want to make sure that those resources are not only safe, but ideally they're all talking to each other. And so this kind of ties into energy management, power control systems, really as a theme, I'd say, for the next few years of our industry's deployment. Thinking back to UL standards here, what we have on screen is UL 1741. Likely a lot of you in the audience are familiar with this. This is our certification listing standard for grid interactive devices. So we most often encounter it with grid interactive inverters. The UL listing has what we call a CRD, so another acronym, Certification Requirements Decision. We just chatted about what makes a consensus standard. UL 1741 CRD is not a consensus standard. It is a CRD, which acts as almost a bridge to a formal consensus standard in the future. In this case, 1741 was our grid interactive UL listing. As Ryan mentioned, in NEC 2023, we have a really meatier section in Article 750 on power control and energy management. So UL is kind of acting in line with NEC and giving us some more options to list our products, with the CRD as a bridge to the future UL 3141 listing, which will be consensus, and we do expect this year. Yogesh, in our prep for this conversation, I thought you had a really great way of kind of describing the cause and effect relationship that led to this development. If you could walk us through that, that'd be great.
Yeah, a lot of utilities required non-export. So those who are familiar with, for example, Southern California Edison's net metering handbook for energy storage very clearly states non-export has to be established. And in order to achieve that, but also to certify that it has been achieved, 1741 CRD was written. It was complex. It had multiple modes of non-export, and the NRTLs that could certify were few, but the biggest issue was acceptance. Not all utilities and AHJs were accepting it. And there, I think, is the genesis of 3141, where the requirement for non-export and also load control is now formalized in an outline of investigation. It will require the manufacturers to test comprehensively, have multiple NRTLs that can do this work. It will remove ambiguity. And once the outline of investigation phase moves over into a standards phase, it will also address the uncertainty of which utility is accepting this and not accepting this. Developers and EPCs who went through this know the pain. You not only had to figure out who can do it, even getting access to the standard at times was hard. And then you had to get it listed on the California Energy Commission's website. So a lot of hardship, eventually led to a standard that streamlines two things, non-export and load control.
Yeah, and I think that's maybe another important thing to mention. And again, thinking back to NEC 705.13, kind of the impetus for this initially was to safely prevent overload on our system bus bars. So we want to make sure our main service panel never exceeds its rating. We want to make sure the same is true for any aggregation panels in our system. And a PCS or EMS kind of lets us transition from more physical constraints to programmable ones. So now we can use current set points for our calculations in place of just the maximum continuous output current we would find on a data sheet. So gives us a lot more flexibility, potentially opens a lot of doors to oversizing resources, whether that's a source or a load, and then starting to allow all these devices to talk to each other. And where we're seeing that more and more is not only smart sources, so smart interactive inverters, but also smart loads. So maybe we can shift certain loads from one time of day to another, ramp them up, ramp them down in a more dynamic fashion.
Yeah. And Lucas, one exciting way that I am eager to see is how the EV charging industry uses this standard. I think there is so much potential in there for them. So imagine if you, with the ancient scenario, wanted to put in 4 DC fast chargers. The code was black and white. The load associated with that had to be borne by the service entrance. If you did not have the amps, you could not do it. In the future, with 3141 and load control being approved with this device, I could say that I'm utilizing those chargers one at a time and actually have a lot of kilowatts of EV charging connected without expensive facility upgrades. So I'm very excited to see how the EV charging industry innovatively puts this to use.
Yeah, I think the vehicle to everything is going to be a big next step for us as a industry as a whole. So I see that we're going to be up against time, and I see also some questions. So I'm going to jump over to this operating modes slide. I think this is one that has been helpful. Lucas, I think you've had some really good talking points on this. So as UL 3141 comes about, we have different operating modes. And then correct me if I'm wrong, all of which are not required, but this is, different potential operating modes that fall under that EMS umbrella. And so can you kind of walk us through some of these and how this might look for folks?
Yeah, that's correct. And so really thinking present day, a lot of these operation modes are optional. And so one of the pieces that we skip past, but I do want to briefly mention is just if you see something listed to that UL 1741 CRD today, take that with a grain of salt. It won't be able to necessarily perform all the functions you see on screen here. So if you're looking for a PCS today, make sure you follow the documentation trail and determine whether or not it actually can do what you'd like it to. But like you mentioned, Ryan, what we have on screen here are just a few examples of what that could look like. Most of these systems, or all of these systems really do involve energy storage, some PV as well, all just different grid interactive modes that you could very well see an AHJ, a utility, even a system owner requiring. And what's exciting about 3141 and really the future of this is you can envision a world where your system changes operating modes dynamically. Maybe a utility goes through seasonal change where they allow you to export more when there's more load on the grid, but they want you import only at other times. And so lets us kind of talk more dynamically with the grid itself. But Yogesh, I see you've got more to add here.
Yeah, that was exactly unfolding with the three IOUs in California. Their net metering handbooks very strictly said non-export, but they also wanted folks to participate in demand response. So now you had straight conflict. You could not export, but on a summer day, if the grid was running out of power, the behind the meter systems were being asked to participate in a demand response program, which would have been impossible. UL 3141 allows that to become a reality in a very simple way.
Yeah, and so, these export modes, again, are going to be part of the 3141, and this is really how the manufacturers go about and the way 3141 is written. So as Lucas mentioned, we are seeing already folks, manufacturers specific listing, or putting out on their data sheets, 1741 CRD compliant, things like that. And so, as Lucas mentioned, understanding what that actually means, what is the operating mode that they are applying here is an important part of that. And California CEC listings, all that kind of stuff, that becomes part of that question. All right, I'm gonna jump. We're getting really close to time. I really appreciate people's times. There's at least one other thing, Tyson, your question about consensus standard kind of generated some chatter there. So just kind of want to, since it applies to both 3141 and what we're talking about with the CSA, that consensus standard, to become consensus standard has to go through the ANSI process. American National Standards Institute, that's what it was. And, they have specific requirements on what it takes to go through that process that Yogesh was talking about to make that. So I think that was a big one to kind of point out there. And also, do see that there's a number of questions here that we're not able to get to. I would love to continue the conversation with folks. As you have other questions, feel free to reach out, and I'll show our contact info here at the end. So some, big key takeaways. We are, seeing evolution in our codes and standards, and we do have, movement from 9540A to a, fire standard, or excuse me, large scale fire test. And, some of the other one big point here, and I'll open it up to you guys to kind of help me close out here. But the codes and standards, that they work in conjunction with each other. So for example, we kept talking about 9540A and 855. There's a relationship there. 3141, 1540 IEEE. So there's definitely relationships within those, and that's an important aspect of the development and application of all of these. All right. So as we close out, just again, thank you for your time at Mayfield Renewables. We have some courses on these topics and others. I invite you to take a look at our website, see if there's other courses, other material out there that would be helpful for you and as you're working through some of these questions in the industry. So take a look at that, and would be excited to have folks join those classes. And then kind of last two slides here. Next month, we're going to continue this conversation about fire risk with ESS. Matt Pace, Mike Nicholas, that from PNNL and Hiller going to join us next month. We're going to talk about more of these fire situations and kind of the how we're approaching the risk and how we're mitigating on those. So would be excited to have you have us join next month. And then finally, thank you to the three of you for joining. Thank you out there in the audience. If you would like to get a hold of us, if you'd like to talk to us, here are our different contact info. You can, phone number, generic email over there as well. And would love to hear from you and continue the conversation. So Lucas, Tyson, Yogesh, thank you all so much for taking the time.
Thank you.
Thank you.
Thank you so much.